Today I'll show how to design the purchasing shear analysis. We have a slab of 175 thick, average effective depth 145 mm, constructed with C2530 concrete reinforcement with 12 mm bar at 150 mm center one way, 754 mm square per meter area, and 10 bar at 200 mm center in other directions, 393 meters square. Determine the maximum ultimate load that can be carried on the area 300 into 400 mm. This is our the cross section. We have the average depth 145, overall height 175, is 12 mm bar at 150 mm center 2 yes, and longitudinal bar 10 mm bar at the rate 200, spacing 393 meters square per meter. This is the column which we are going to design the punching shear analysis. We have the B400, A300, and this is the precise control parameter reinforcement in section, which is 2D, to of the depth, every depth. Now we'll carry the circumference of the circle. Circle circumference will be pi d, means 2 pi r. R means that will be 2D, and 2 pi r is 2d, that is 4 pi d, and overall circumference is equals to 2 times a into b times 4 times 1 2 3 4 corner 4 into 4 into pi d 322, which will carry our circumference. And this is our shear strength. This is our shear strength, which will be RD small bd into perimeter, where we have depth 245 into 3222, and we have this one in mm. So we need to calculate. We'll get the BRDC. For BRDC, we need to calculate average steel ratio. That means delta 1 is equal to delta yx into delta zx, which we can get from his code 6.44. Yeah. Let's go. Now for delta 1, it is area of steel into BW into D. We take the width as 1 meter, so it is 0.0052 del zit. We calculate steel, and delta 1 is we calculate it is 0.038, 0.38. We take it 0.4%. Now we need the concrete modification factor for this one. So this is the concrete modification factor for our effective depth is less than 200. So we are going to take this section for here. We have the y. We have the steel percentage of 0.38, which we do not have here, 0.38. So 0.38 lies between 0.25 and 0.5. So we do the interpolation factor. And another one is concrete steel modification factor. For our we have 25, so we are doing the modification factor of 0.94, and here is here. We calculate the BRDC, means shear resistance of slab without shear reinforcement. Without reinforcement we calculate it. This one we get from the interpolation, and maximum shear reinforcement is called 0.94 is the modification factor, which we get from here. And then after 0.56 is the shear resistance of slab. Then we have the circumference here, and this one is we change into kilonewton per here, and we calculate 248.6. And this now we need to calculate the maximum shear based on the face. The area is given by maximum shear resistance BRD. That means at the perimeter of the loaded area. So BRD is max, how much maximum it can load it. It means 0.5 B1 into FCD, perimeter of loaded into D. So this is strain reduction factor will be 0.61 minus FCK into 250, and this is the perimeter of the loaded area, and D will be depth. So design strain will be FCK into alpha cc FCK gamma cc. This we get from the code. This in we have designed in the beam section also, and for gamma cc it is for 1. For rest of in our beam section we design 0.85. For shear FCD is equals to 1 into FCK into 1.5. This one we get from the table. Wait, I'll show you the table. show the table. Right. Where is must be somewhere here. Yeah, here. Yeah, we have this one from here. Design compressive strength. Now we get a table. By here is our formula. Now we need to. It is written here. It is in. Yeah, here is a value we take from this table. Yeah, elastic deformation. Okay. After that we can add BDC is equal to 0.5. We put the value and we get U is the loaded area. For this load area, it will be only the section. This perimeter section is 2 into A plus B. And after that we change into kilonewton, and this is our the maximum shear resistance. But basically the maximum load that can be carried by our conjugate shear is 246 kilonewton, which we get from here. 8.6 maximum load carried by the 246 here. Yeah, 200 foot. I think this is the load carried by our reinforcement. Thank you for watching. By this way we can design our shear analysis, punching shear analysis we can done by this. Thank you for watching.